Okay, so we're live. Welcome everyone once again to the workshop series for Polygon DevX Global Tour. And this is the second workshop we're on. Today we have Tony with us, who is a software developer and a lead DevRel at Polygon Labs. Welcome, Tony.
Thank
Super excited, super warmed up after the first workshop kicked off yesterday with Circle. Super excited to have you today as well. Please feel free to share some opening thoughts with the developers, hackers watching us today, and then take it forward from there.
Yeah, well, I just want to say, like, I'm really excited to be here. It's been a very engaging process just watching the DevX tour take off across multiple continents, multiple cities, and I'm just really excited for this particular leg with Europe and EMEA and the hack, and just to see everybody here and to see what they'll be building and so on and so forth. So I'm really
Perfect.
stoked about that.
Thank you so much, Tony. And I would also like to extend a vote of thanks for Polygon for consistently supporting the developers in multiple fronts.
Yeah, yeah,
Yeah,
yeah.
feel
So
free to take on the stage and present your screen and get started with the workshop.
okay, cool. Yeah. Let me know if you're seeing. I have my slides on the side there. Okay, great. So
Yes,
this
yes.
is okay, great. Yeah. Well, thank you very much, everybody, for being here. This is a really great opportunity for us to just look at this Polygon zkEVM and how you can get started on that. And so, just to get us going, my name is Tony Olendo. I'm the lead developer relations engineer at Polygon, and I am at Tony Olendo on Twitter and on Telegram. So anytime you want to reach out, please go ahead and do that. And at Polygon, what we're looking to build is blockchains for mass adoption. And we have a very strong open source ethos that allows anybody to contribute to the future of decentralization. All of our repos are open source. You could add contributions, you could help build out various aspects of our tech, and we are open source by default. And that's why we really believe that we want to create a more equitable future for everyone. And our mission and our goal is to become the value layer for the internet. And what do you mean by a value layer? It's just basically a protocol that allows anyone anywhere to exchange value in the same way the internet allows you to exchange information. So how easy it is for you to message somebody across the world is almost like a no-brainer at this point in time, that you could message a family member halfway across the world in a different time zone and location entirely. There was a time that this wasn't possible, right? You had to write a letter, you had to wait, and all these things. But now we have that. If we have an instantaneous experience when it comes to our communication. Now, what about transferring value? If you have any kind of digital asset that you want to be able to transfer, it's very difficult for you to do so in the current iteration of the internet. And part of what we want to do is just want to enable a value layer to be built as one of the strongest use cases for Web3. But what should a value layer look like? It should be secure, it should be scalable, and it should be unified. And part of what we're focusing on is we have three primary solutions. We have the Polygon zkEVM, we have the Polygon, well, soon to be zkPOS, and we have Polygon SuperNets. But today we're going to be focusing primarily on the Polygon zkEVM. And what is it? It's basically a scaling solution that is meant to um, help help scale Ethereum. And we do that by using, it's a zero knowledge rollup, and we use zk proofs to reduce transaction costs and increase throughput. We don't have full support for the EVM, but we just have a couple of pre-compiles that are still pending, but we'll have everything ready maybe hopefully by the beginning of the year or something of that sort. Um, and so what exactly is the ZK rollup? Basically, let's start by defining zero knowledge. These are basically used to prove the validity of a statement without revealing the statement. Used to communicate state transitions, specifically in an EVM. We use zero knowledge proofs to communicate state transitions. Um, and a rollup essentially is a layer 2 scaling solution that increases the throughput in Ethereum. And rollups are particularly useful now because they're able to scale and process thousands of transactions in a single batch, and then only post a minimal summary of that data to mainnet Ethereum, right? And that's the value of what we're doing. And with zkPOS, we'll have a Validium that essentially allows us to do the same without having using Ethereum mainnet for data availability, but we'll have a distributed network of um, um, uh, data availability nodes. And essentially, zkEVM rollup is a type of a zk rollup that it mimics the same transaction execution environment, and there's some different implementations of what that looks like, but essentially what they allow you to do is just to have a bunch of transactions sitting inside of a zkEVM layer 2 solution, and they're processed on as a single batch, and then a validity proof is posted, a single transaction that represents all of that batch of transactions is posted to Ethereum, to a single Ethereum block, and that's how it kind of inherits the security of Ethereum. So this is a just a brief summary of what zkEVMs and specifically zk rollups look like. And there's optimistic rollups that you could also consider as well. Um, so the zkEVM beta is the next chapter of Ethereum scaling. So it allows you to scale, seamlessly deploy most contracts while retaining the inherent security of Ethereum, and with the goal eventually, excuse me, with the goal eventually being faster finality times and lower costs. Um, if you want the official documentation, you could go and read up more about the Polygon zkEVM here. But specifically, I want to jump into a specific example that we'll go through together, and it is my climate coin solution. And if you scan that QR code, it'll take you to my repo where we have a basic contract that we're going to deploy together to the zkEVM. Um, and this is what kind of enables a really straightforward experience, and to be able to demo that. So I'm going to stop sharing my screen now, and I'm going to switch to um, my other screen. So just give me a second. Okay, Ishika, okay, great. Yeah, thanks. Um, so let's begin by looking at my climate coin contract, right? So this is a basic hard hat file that yeah, so this is a basic hard hat file, well, project that enables you to deploy a contract to Ethereum. So let's get started here. So first thing, as usual with any contract, we define the pragma, and we're importing the ERC20. And the goal of this contract specifically is to look at it in the context of like um, uh, carbon credits. And so we use an ERC20 to kind of like be the reward token. So we have a climate token here that we're calling, the symbol for that is CT. And essentially what we have is a couple of different functions that look like a standard Ethereum smart contract. We have a function here that allows checks if somebody's an admin or if a particular address is a farmer. We also input how much acreage you have as an individual, and then if you have any claims. So basically, how it works is that once it's deployed, hello, okay, I don't know. It looked like it hung there for a second. Which could I get like just a thumbs up
Yeah,
letting
yeah,
me
it's
know?
all good now.
Okay, all right, cool. Um, so we have this particular function here that allows you to add a claim. Um, and then we also allow you to register a farmer as well. So you register a particular address as a farmer, and they enter the wait list. And then after that, they're approved as a farmer, and you basically pass in the address and the acreage the farmer has, and that's essentially stored there. Um, um, and once you have that, you could add a claim. I'm not sure why my screen keeps hanging. This is very strange.
We'll just prompt Tony to rejoin. I think he was facing some network errors. Yeah, I'm sorry for the inconvenience, everyone. With the online session comes the online connectivity saga. But just hold on for a moment. I'm sorry, guys. Just stay with us for a moment. I'm just checking in with Tony. Okay, it's back. Is it all good now, Tony?
Yeah, for some strange reason, my computer just crashed.
Yeah, no problem.
Yeah, never found that happen to me before. Anyway, I've set up my screen for sharing, so
Yes, we can see it now.
yeah, sorry about that. Yeah, so again, it's a fairly simple contract. I won't go through the full features of it. You could review it online, but basically, you could add a claim, and once you add a claim, it's processed and so on and so forth. But I'm going to just show you how to deploy this to the zkEVM, right? So once you have your hard hat contract kind of set up, it's going to come into the hard hat config here. And how do you go about that whole process? So if you're looking at your hard hat config.ts, you're basically adding the zkEVM's URL here. I mean, the RPC, excuse me, the RPC here, where you could add that and you have that available there. Um, then you need to add like your zkEVM um, uh, API key. And how do you get that? You go to um, um, just give me one sec. So if you check out like your zkEVM polyscan, you're able to see what that looks like there.
Hey, Tony, seems like your video has paused. Oh, can you hear me? Oh, yeah, you're back.
Yeah, sorry about that. I was just switching Wi-Fi. this is the Polygon zkEVM screen, and if you come, so this is Polyscan, which is like a fork of Etherscan, and if you come to your profile, you get your API keys. I won't show you my keys. Yeah, you could apply for your API keys, and you could include that in like your .env. So if you come here to the .env example, you could see I'm adding a zkEVM Polyscan key, and when I check that, when I add that here, it means I could call it inside of the hard hat config here, and it's available to me now. So you could add whatever the URLs, RPCs you want, but I'm also providing my private key inside of my .env example. Then from there, you need to add like the actual key that you get from Polyscan. So the zkEVM key is added there. And then the most important change you have to make is when you're adding custom chains, right? So we have a network that we're calling zkEVM. The chain ID is 11001, and your API URL is this here. And this basically, all of this aids in the verification stage. So for now, let's look at this from the perspective of deployment, right? So let's start by deploy the zkEVM. So I'll see Diamond Coin. And this is the command I'm running. So I'm just running script/deploy.ts, and that essentially should start the deployment process. And of course, as you all know, whenever you're doing a presentation like this is when things go awry. In case that happens, please bear with me. Cool. All right, so now that's been deployed. And if I come into the Block Explorer here, and I add in that address, I could see that my contract was deployed just now. And it's because it's the same one as one that I had uploaded before. It's already automatically verified. But let's say I want to be able to verify that myself. I would come into the, so basically once it's deployed, there's another command, which basically I'm putting in the verification, and I'm specifying the address here of what I want verified. Now it's already been verified, but this is how we would do it. So I'm passing in like the parameter, and this parameter is a constructor argument that defines the additional number of decimals. And once I deploy that, yeah, so it says already verified, right? But basically, that's all you need to do to have those kinds of transactions there. And once you have that, you come to Etherscan here, Polyscan here, and you could read state or you could write. So let's try and go through the flow in terms of how do we add different people. Yeah. Okay, so now I'm already connected. And I could choose to add any address. So I'll add one of my other addresses here as like, I guess. So I'm taking one of my sample addresses here, and I could add a farmer. Register farmer. And here I'm putting in the address of that particular farmer, and I can write. And the transaction essentially goes through there. Merging on that transaction. Oh yeah, I can see that was successful, and I could continue to do um, uh, most of those functions there. But essentially, I was showing you like what the functions of that particular contract are. But I think we're probably at a point where we could wrap up. So what have we covered here? We have a sample contract here with standard Ethereum functions and so on and so forth. You get all this information there. Um, from there, we're adding, there's a couple of significant changes you need to make to your project to make sure it works. So you add a network. So you add the RPC of that network and your private key. You get the Polyscan key for zkEVM, and you're basically adding it as an API key, and then introducing a custom chain now with the network zkEVM, and that's the chain ID. And from there, you're able to deploy. Simple, just two commands essentially, and you're essentially off to the races. Unless anybody has any further questions, I think that's probably it for me. But that's how easy it is for you to get started with zkEVM.
Thanks a lot, Tony. Can you just quickly show us the slide where you had your username in order to for any dev or hacker to reach out to you in case they have any question, query, feedback?
Yeah, for sure. That would be
Perfect. Thanks a lot. So now you know where to reach out, Tony, in case you're facing any issues with deploying on zkEVM. And that was it for this workshop. We have another one lined up in 30 minutes from now. So yeah, get yourself some tea, coffee, stay hydrated, and then let's hop to the next one. Meanwhile, thanks a lot, Tony. Thanks a lot for spending time with the developers today. Yeah, that was it for this workshop. And if there is there anything else that you want to mention for the hackers with us today?
no. We just have really good bounties available, as you guys would know, and so I showed you like the base for what we'll be considering. You should deploy to the zkEVM testnet, and that'll give you a really good experience. And from there, we could consider, because the types of applications you could come up with could be anything from DeFi to NFTFi to anything like a climate solution, like I showed you now. So the range of the spectrum is pretty broad, and I'm looking forward to reading your submissions. If you have any challenge with any bit of this whole process that I've demonstrated, please feel free to reach out to me. And yeah, good luck.
Yeah, thanks a lot. Yeah, for the developers, we have around $80,000 in bounties, and the hackathon does not actually end up here. There is a lot of opportunity for your project to take off from this and be a part of an exclusive team, which would be mentored and taken care by the Polygon team. Yeah, so all the best for all the hackers building, and yeah, I'll see you soon in the next workshop.
Cool.
Thanks a lot, Tony. Bye, everyone. Thank you for attending.